Hey guys, what's up? This video again belongs to the 50 Rust project playlist series. Now this video is optional in the sense you don't have to do it because here we're going a little off topic. We're going to be building for Ethereum in today's video. So it could be slightly difficult for some people who have no idea about how blockchains work or any idea about Ethereum, but it's going to help if you already have a lot of idea about Ethereum, if you know about Solidity, if you've been in the Web3 space, you'll find it very easy to follow along because you'll know all the underlying concepts like we'll be creating a wallet and accounts and all those things. So today we'll be basically building with Ethereum. Now, my suggestion is even if you don't know anything about blockchains, just watch along this video and see how Rust is used in this kind of a video, and you might just learn something. But like I said, it's optional. You don't have to do it. It's completely okay if you don't want to get into Web3. But I have these little bit of Web3 videos here and there in this series just to engage all the people who are learning Rust specifically for the purpose of Web3. Okay. Now, you have a very popular framework in almost all languages for building for Ethereum, right? You have Foundry for Rust, you have Brownie for Python, you have Hardhat for JavaScript. Okay, so you have all these really popular frameworks that not only allow you to build very easily, like completely scaffold an application, an Ethereum application. And by scaffolding, I mean that you get a folder so that you're putting your Solidity files in it, and then you get to build it, you get to compile it, and you get to deploy it very easily. So that's how scaffolding works, right? So you get to do all of that very easily with these frameworks. Now, there is another software called Ganache, which enables you to run your own Ethereum node inside your own machine, like your own Ethereum blockchain locally, and then check it out. And Hardhat also has something very similar like Ganache inbuilt. Foundry also has it. Brownie also has it. So all of these frameworks are kind of very, very similar. Now, with Golang, you also get Geth, which is the official Ethereum client for Golang. And you can do a little more things here, like, all of these frameworks kind of utilize Geth in the background, like at least some of them do. So Geth is the essence, right? All the frameworks, they kind of utilize the technology of Geth behind them because this is the original OG Ethereum node. So you can start like a complete node and complete manage a node. And by completely managing a node, I mean that you can use, and you can, like right now, go to AWS, start your own Ethereum node using Geth, right? I'm sure you won't have the money to, stake, and that's completely okay. But you could do that if you wanted to start your own node. You could do that with the help of Geth. Okay. Now, just like you have Geth, Rust, the Rust community is also building. The guys who built Foundry, I think, are building Reth again for working with Ethereum. It's complete Ethereum node or client with Rust. All right. So all of these technologies exist in the ecosystem. But today, what we're building is for Ethereum using Rust. And you might think that I'm either using Reth or I'm using Foundry, but I'm not, right? We are not using Foundry today. We're going to be building from scratch. So you would understand how the creators or the builders of Foundry, what they were thinking when they were building Foundry, right? So we're going to write just basic like Rust code from scratch and going to work with Ethereum. So we're going to have our own wallet. Okay, we'll first create our own wallet, and we'll be using provider. And just like you have Ethers.js, you have Ethers.rs, and I'll explain why we need it. We need this package. Okay, and then we'll also be needing Ganache actually. So we'll have our own provider, which will basically help us to do some JSON RPC calls with basically to interact with Ethereum. And in our code, we'll have the ability to create. Let me zoom in if you're not able to see this. Actually, maybe the font is too small, right? You'll have the ability to create, sign, and send transactions, and you'll also have the ability to compile smart contracts. Like I said, what do these frameworks do? They give you the ability to scaffold, in the sense ability to create, sign, and transactions, ability to compile smart contracts, deploy contracts. These two being the most important points. And this is something it's important, but these two are, in my opinion, more important because you get to compile and deploy smart contracts. Now this means that this also means that we won't be writing our own smart contracts. This is not a Solidity tutorial. We'll be taking some Solidity code and putting it in a folder. and then we'll write the code around it, the code that was supposed to be done by something like Foundry or Brownie. We'll write all of that, not all of that, but a lot of that from scratch in our project. Okay, so I hope that makes sense. This project can be slightly complex, but it's also going to expand your horizons like nothing else. So I would recommend that you follow along if you can. I have all the code already is there on my GitHub. So you just have to go to my GitHub, which is Akhil Sharma 90, in case you don't know. You have to follow me on GitHub, guys, because I put all these awesome projects there. So you can use them for research. You can use them for future projects. You can use the code. Okay. So you just search for Ethereum or Rust Ethereum project, and you'll find this code already there. It's been like lying in my GitHub for a while. I've been meaning to make a video with it. I posted about this on my LinkedIn, but I've just not been able to get around to create a video on it. Okay. And finally, I found some time today. So I'm just building a video around it. So I hope that's a great introduction. Now let's get started. So now my t-shirt has changed. It's because I'm shooting on a different day. I couldn't continue shooting yesterday because I don't get like more than 15-20 minutes at one stretch. So I just keep collecting these videos and I make the big video out of it, and then I put it on YouTube. That's how I'm uploading content. That's why it takes a while for me to upload content now. I'm not doing it as often as I used to, but you know, I'm just getting like 15-20 minutes a day. Anyhow, so what I realized that I didn't show you yesterday was what our program is going to do. I didn't explain it to you. So our program basically is going to first start a Ganache instance. Ganache is our own local Ethereum blockchain working on our local host. It's going to add some Ganache test wallets by using deterministic mnemonic words. So mnemonic words, basically, if you've ever created your own wallet, like let's say MetaMask account, you would get these words, right? Those words that help you create your own wallet address. And then you'll get the private keys and you'll convert them to your local wallet instance. By the way, all of this is happening through commands. So when you go to something like MetaMask, you do it, you click, and you do it through the UI. But the original way is to do it through either the CLI if you use get, or in our case, we're going to use some commands with the help of a library that's just going to trigger these things for us. And we're basically going to help, we're going to be able to do all of this through code, right? Not through the UI, right? So you've done all of these things, but you've done it on the MetaMask UI, okay? Or you've done all of these things, or you've done it through the get CLI, but we're doing it with the code, the Rust code in today's session. That's what it's all about. We'll create a client to connect to the Ganache endpoint. So we'll create our own client. We'll query the balance of that account. And so we'll as soon as we do these things, we'll keep printing them out to our terminal. So like, for example, if we query the balance, we'll print out that balance in the terminal. We'll make a simple transaction. We'll then compile the complete Solidity project. We'll inspect the compile project and we'll deploy our contract. So all of these different things our program is going to do. Okay. So now with that out of the way, now we can actually start building the project with you. So what we can do is we can start creating our project. I'm going to say cargo new, Rust, ETH, and YT for YouTube. And I will cd into it ETH and YouTube. And here I want to open this up in my code editor, but before that I will say cargo install cargo edit. Okay, so I'll just wait for it to resolve. This will take a while. This will and obviously we have to add many more libraries, right? So we need Tokyo for asynchronous functions. We need for handling command line arguments, we need this very famous library called clap. We've used Tokyo before, and clap is something we're using for the first time today. Okay, we need hex for handling hex strings. And we'll need IRE, EYRE. I don't know how you pronounce it, but I pronounce it as IRE, EYRE. And it helps you to reduce, it helps you to basically handle errors in a much better way. So this is taking a while. What I'll do is I'll just come back in a second. So now I can see that my cargo edit was installed. Now a lot of you may not know about cargo edit, but it's very commonly used. It just helps you to from your command line, you can just edit your toml file very easily. So you have the ability to remove like cargo rm, cargo upgrade, cargo set versions. All those commands you'll get access to with the help of cargo edit. So just when develop, just like at the time of development, it's a very handy, very useful package. Now what I want you to do is open this up in your code editor. As you can see, I've changed the theme around. It's not the same anymore. In my cargo.toml file, I'll put the author as Akhil Sharma. You can put your own name in the author. And for the dependencies, just copy and paste everything that we have from my GitHub file, okay, from toml. So here you'll get the IR package to work with errors, hex to handle hex data, Tokyo for async. You have tracing subscriber, you have clap, and we'll see all of these. We'll work with basically all of these in a while. All right. Now the reason, I'm not sure if I've told you, but the reason we need clap is because you want to handle some command line arguments, and clap will help us do that. Okay, so let's actually see how to do it. So here I need instead of my main, I'll just delete my main. I need two files here. Okay, I need two files. The first is the simple transactions.rs. The second is contract deploy.rs. All right. And then I need another folder for my examples. Now this is where I'll keep my Solidity files. Okay. So all you have to do is you have to just copy and paste the Solidity files from GitHub. Okay. Those are the exact examples that we'll be working with. So you just have to copy and paste those examples here, and that's about it. Now for simple transactions, firstly you'll need time and duration. From the standard library you'll need time, duration. Then the ethers package, and firstly you talk about prelude. Prelude, when you see something like prelude, it's saying that almost everything that the library has, get it, but especially these ones: address, local wallet, I need the middleware, I need the provider and the signer, the transaction request. If you're familiar with blockchains and how blockchains work, or how Ethereum works, for example, I'm sure you understand all of these terms very, very well. Then I need some utilities to be able to interact with Ganache. Then I need my error handling library IR, context compat, result, use hex, and I will need two hex to be able to work with hex data. And this is where I'll use my Tokyo for async functions. So we've done this many times before, Tokyo main. So our main function, async function, is going to have result. And here we will first create our mnemonic. Okay. Now I'm going to copy and paste the mnemonic from GitHub. So go to my GitHub file and copy and paste the mnemonic. And usually when you must have worked with, I'm sure everybody by now has created a MetaMask account. You've already received a mnemonic like this. It tells you to store it. It's sometimes there are eight of these character words. Sometimes there are 16 words like these. I think this is 5, 6, 7, 8, 9, 10. There are 12 words in this one. So this is 12. It can go up to 16 basically sometimes. So this is your mnemonic. And when it comes to wallets, you know about addresses and local wallets and middleware and provider and signer, transaction request. So in case you are very, very new to blockchain and you don't know what these terms mean, you might need to like read a couple of articles, and this is not very complex, really, really straightforward. So we'll say mnemonic, Ganache new mnemonic, and we'll pass our mnemonic there, and we'll spawn, and we'll print ln the HTTP endpoint for Ganache. So HTTP endpoint Ganache.endpoint. All right. So first, what we have done is we have spawned a Ganache instance, as you can see, with the help of the mnemonic, and we have printed out the Ganache endpoint. Now this is the endpoint that we want to interact with. Okay. So firstly, we'll get the first wallet managed by Ganache. So we'll say wallet, local wallet being this. So we'll be using each of these things here and there somewhere. Okay. So firstly, now we're starting with local wallet, and here we'll say Ganache dot keys 0 dot clone dot into let first address is equal to wallet dot address. Okay, and we'll print ln wallet first address first. Now this is where we need to work with hex, so I'll say underscore hex string hex encoded string. Okay, so I'll be able to print out my wallet first address with the help of encode hex and string. All right, this is a comma actually. Now let's create our provider. So let provider equal to provider, right? So we are using all of these things one by one. Now we're using the provider. Okay, and provider try from Ganache.endpoint dot interval duration from millisecond and now that you have the wallet and you have the provider, now we'll be able to get the balance of any account. So let's try to get balance. So we'll say first balance is equal to provider that we just created, provider dot get balance, and we'll pass our address first underscore address comma none dot await. We can use async await because function is async, so whenever you call an API or an endpoint, query an endpoint, you will use await. And here we'll say print ln and the first address balance is first balance. Nice. All right. So not only this, which is the first address, not only the first address from the local wallet, that balance, where you can query the balance of any address on Ethereum. So what you can do is we can get an address like this. Okay, you can just copy and paste this from my GitHub code, this complete address. This is a hex address, and our variable, which is other address, takes that same address and parses it as address, and then we'll have the same thing, which is provider.getBalance. Okay, instead of first address, we'll pass other address here. here we'll term that as other balance. Okay, so as you can see, wherever we are printing stuff out, right? Printed and printed and printed and these are like all independent programs. So I'll put these here, just comment like that, just to show you that we're printing out different things. So here we'll print something out, then we'll print something out, right? We're first printing out the Ganache endpoint on which we have to call. So this will ideally be something like localhost 4535, whatever the address. This will print out that. This will print out the address of the first wallet. This will print out the balance of that first address of the wallet. And then this will print out the balance of another address, another random address from the balance. And but we have got this balance here, another balance, but we want to print this out now. So to print it out, I'm just going to copy and paste this exact thing here. Sorry, here. And here we'll say balance for address. And we'll print both things out. So we'll print out the address also and its balance also, right? So here two things I'm going to print out. One is going to be the other address hex, comma, other balance. So this will be printing out the address. This will be printing out the balance for that address. Okay, very straightforward. Now what we can do is we can create a transaction request. Actually, what we can do is whatever we have done till now, we can try and run it. Let's see if it works. Okay, so I'll say here I'll say here cargo bin cargo run bin transact. Let's see if it works. Get all these packages for us. We'll build it. Okay, well, that happens in the background. Let's continue with our code. Okay. So here first, let's create a transaction to transfer 1,000 way. So I'll put comment here again because we printed something out. Here also I'll print comment because we printed something out. And here we'll say let tx equal to transaction request pay other address, comma u256 from u64 dot from first address. Okay, and receipt is equal to provider. We need provider to send that transaction, so we'll say dot send transaction tx comma none, tx being this transaction out here. Okay, and then dot await dot long message pending transfer or confirmations. One dot await dot context missing receipt println. Okay, so we'll send the transaction here. Okay, we'll send the transaction and then we'll await. Okay, and then we'll print out transaction mined in the block. Sorry, transaction mined in block, comma receipt dot block underscore number dot context cannot get block number println. and here you'll print out other address hex, okay, and provider dot get balance of other address, comma none dot await, and then okay. Now let's just go over this code quickly, because like the whole thing. So first we start by getting ethers in. We need to handle errors. We have our hex to work with addresses. We get our mnemonic in our main function. Ganache starts off a new spawns off a new Ganache instance. We output the HTTP endpoint. Now, this is the one that we need to talk to. Okay. First we get our local wallet, right, with the help of spelling is wrong here. Ganache.keys. Okay, so our first address has the wallet address. Then we'll print out that first wallet address. Then we'll create a provider for the Ganache endpoint, right, to be able to talk to the Ganache endpoint. Now we want to query the first balance, right, the balance of the first address being the address that we got here, the first wallet address. So we'll get that address here. After that, we want to try out another address with for hex. We'll parse it and address. We'll get the balance with the help of the provider of this new other address. Finally, we want to create a transaction. So we'll pay other address from the first address. Okay, other address from the first address. Now, to send this transaction, now you have this transaction request, but to send it, you need the provider. So you'll send the transaction with the TX is the transaction. Send it. Now you know that you have a sync, so you'll have a wait here. You'll wait for this transactions to resolve. Essentially what you're looking for once you send the transaction is this confirmation. You want this confirmation, and that confirmation is in fact the receipt, or you would get the missing receipt error, and you'll print out that the transaction was mined in which block. Now to get that, you'll get the receipt because you have the receipt. You'll get the block number, right? So sometimes when I'm typing I don't explain it, but after that definitely I'll explain the whole code to you. Right, so you'll get the block number, and then if the block number is not there, you'll get context cannot get block number. Okay. Then you'll print out that the balance of the other address hex is getting the balance of other address, and so on. Okay, and this is the entire program. Now we can go ahead and run this program. So you might remember that in the background we were running our program. We're trying to run cargo run bin transact, and I did it twice. I got the same error. The error is on line. Is this line, the use ethers line, which is out here, because there's a typo there, use ethers. Now there will be many more mistakes here, so that's why it might help us to turn on our Rust analyzer, which I showed you in one of the earlier videos. So I'll just enable it quickly and see if it gives me any more issues. So it's going through a cargo check, as you can see down here. It's going through all the checks, and will tell me if there's any issue, hopefully. Right, so everything looks okay for now. Yeah, let's try it. Okay, it's giving us red in two areas, in two places. So I have to find the red lines. I can't spot them right now. Is it happening because of this? It's not a red line, right? Yeah, there's nothing here. So I'll just try running it anyways. Let's see what happens, and then we'll wing it from there. Yeah, so it's talking about context compat only, and it's also talking about long message. It should have been log message. It's saying it should have been log message. Oh yeah, sorry, it should have been log message. Okay, my bad. Yeah, so I can see the red line here. It should have been log message. Okay, fix that. Now everything seems to be fine, right? So now let's try running our program. Let's see what happens. All right, so the first thing we were expecting to print is the HTTP endpoint. Okay, so let's check it out. HTTP endpoint is the first thing we were printing, HTTP endpoint. So it prints that out for us, which is the Ganache endpoint, as you can see here. It's localhost 38993. Then the next thing we want to print is our wallet first address, and the address of the wallet. So wallet first address and the address. The next thing we want to print is the balance of this address, right? As you can see here, I'll print out the balance of the address. So I do that. Then I want to print out the balance for a random address. So I'll take a random address, I'll print out that random address, and I'll print out the balance for that address, right? I'm doing that, so I'm printing out the address and then printing out the balance for that address, 0. Then pending transfer this much. Okay, so here you'll print out the pending transfer is how much, and then pending transfer is how much, right? Pending transfer, and then transaction mined in which block. So here it's saying transaction mined in block number 1. Okay, and finally balance of the other address is 1000 now, because it's received 1000 way, as we know, 1000 way from the first address to the other address. Okay, so here you had the first address there was so much balance, and the other address there was 0 balance, and now you transferred 1000 from the first address to the second address. That's all this complete program does. So I hope you learned a lot, right? And this is, by the way, a great example, because you've learned you've worked with so many functions in just very less time, and so many important functions like addresses, balances, wallets, transferring, waiting for that transfer to happen, getting a receipt, checking that receipt, all of that, and getting the block in which the transaction was mined. Now, what happens is when I make these videos, right, many people lose patience just in the beginning. Oh, I'm not understanding anything. But you have to wait till you reach a logical conclusion. Like right now, we have a logical conclusion of the first file, and now it makes a lot of sense, right? Everything is now very, very well explained because you've seen it. If I just explain it to you and I don't show it to you, it doesn't make any sense. So I show first and then I explain, so that everything becomes very, very clear.